So, today we will start experiments in laboratory. Okay. We will demonstrate different experiments we performed in our during our undergraduate course. So, basically first year laboratory, second year laboratory, third year laboratory, right. So, in different years we have different laboratories, and we designed the experiment in such a way whatever in theory class students learn different topics. So, on those topics we arrange experiments in the laboratory. Okay. So, before going to lab to do experiment, students should learn about some basic things. That is what so far I have discussed different basic things. What are the basic tools or apparatus in the laboratory we very frequently we use. So, like multimeter, voltmeter, galvanometer, and then slide calipers, screw gauge, then meter scale, magnifying glass, screw, nut, bolt, right. So, basic tools, basic apparatus one should know. So, that hopefully already you know now, because I have discussed all of them, I have showed you also. Okay. So, then also one should learn about the basic analysis in the laboratory. So, for that also I have discussed how to collect data, how to calibrate the instrument, and how to draw graphs, and how to calculate the error. So, when we are discussing how to calculate the error, so also we through this error analysis I mentioned how you have to perform experiment very carefully, so that you can minimize the error, means your experiment will be more precise, your results will be more accurate. So, what is the accuracy, what is the precisions. So, all those things I have discussed. So, now hopefully we are ready to perform experiment in the laboratory. So, let us first. So, again when you are going to perform a particular experiment, so first you should know about the theory of the experiment, means what experiment you are going to perform. So, when you are performing experiment, means you are going to measure some physical parameters, right. So, how these physical parameters is related with the measured parameters, and what are the measured parameters, and for measuring them what are the instruments you require, okay. And then what is the procedure of the experiment, how we will follow the procedure of the experiment. Okay. So, that is what one should know before starting the experiment. Okay. So, and then you perform the experiment, and then next step will be the analysis of data and report the result with errors. Okay. So, basically for performing an experiment in the laboratory, I can make in three section, three division. One is theoretical part, okay. theoretical knowledge about the topics which you are going to basically study through the experiment. So, you should have knowledge about the topics of that experiment and how to perform the experiment, what is the procedure, what are the instruments required. So, before just performing experiment you have to be ready with this. Okay. So, then you perform the experiment, this is second division, second section, and then after performing experiments you will have data with you. Now, third and last section is basically analyze them and report the result. Okay. So, here basically first I will discuss this first section where I will discuss theory about these topics of the experiment and procedure as well as the requirement instrument. Okay. And then I will go to lab and there I will give you live demonstration of the experiment. I will perform the experiment. Basically, I will not take data there because it will take long time. So, I will just show using the instrument different steps of measuring the parameters. Okay. Then again I will come back here with those data and I will analyze and how to find out the final result with error. So, that I will discuss. Okay. In 3 steps we will complete an experiment. Okay. So, let us take an experiment. So, how to measure or determination of Young's modulus of a material. Okay. So, that's what our topics today. Okay. So, we would like to measure Young's modulus of a material, right. So, this is the obviously this is the subject of elasticity. Elasticity. Okay. So, basically that is the elastic property of the materials. Okay. So, we should have basic knowledge about the subject matter, what is the elasticity or elastic property of the material, right. So, elasticity, elastic, when we tell elastic, right. So, there is another term plastic, right. So, what is elasticity or elastic and plastic? So, elastic is basically one can change dimensions slightly or largely by pulling or pushing or twisting or compressing a body. Okay. And it returns to its original dimensions when the applied force is removed. Okay. So, deformation is temporary. If so, then we tell this the elastic material. Okay. And if it does not return to its original dimensions after removing the applied force, then we tell this deformation is permanent, and that's what is plastic. Okay. So, anyway, we are not interested about the plastic, we are interested about the elastic in this subject in this class. Okay. So, there are 3 ways to deform a solid. These are basic things, you know, just I am I am repeating the same things. It is always better to repeat the things when you are going to perform the experiment. So, you should know from the basic. So, there are 3 ways to deform a solid. So, one, if you take a cylindrical form of a material. So, if you apply perpendicular force along the length, then there will be elongation along the length. So, original length is, if it is L, and then after applying this force, if length is L plus del L. Okay. So, then this is the elongation of the rod, and if you here condition is, if release this applied force F, then it will come back to its original length L. Okay. So, it is assumed that this force is applied in such a way that after removing the force, it will come back to its original form. Okay. So, sometimes elastic material, but it does not come back to its original position. So, then we tell this this force limits the cross the limits. Okay. So, there is a limit of this applied force. So, that I think I will tell you. So, another type of deformation can be like this. If we apply tangential force F, like if you apply, so this is the elongated, okay, and this other one just you are applying force tangentially on the surface like this. Okay. So, then it just deforms, it's tilted this side. So, it makes angle, So, this type of yes. So, this is another type of deformation. So, then third type of deformation may occur when this uniform force is applied from all directions. So, just if it is just like pressure, if you put something in a liquid. So, liquid, and then if compress the liquid, then this force will act on the body immersed into the liquid. So, from all directions. Okay. So, these 3 kind, so then this one will be deformed. So, it is let me just tell that this elasticity, it is based on basically Hooke's law. So, what is Hooke's law? Hooke's law is basically linearized stress strain relationship up to elastic limit. As I told, some limit is there, elastic limit is basically Hooke's law. So, according to Hooke's law, this linear relation between stress and strain means stress is proportional to strain. So, stress by strain is a constant, okay, proportionality constant. So, this constant is called basically elastic modulus, and elastic limit the basically the ability of an object to regain, to return its original shape after being deformed by maximum external force. Okay. If you apply beyond this force, then it will not come back or regain its original shape. So, then Hooke's law is not valid. So, that is why this Hooke's law is valid basically up to elastic limit, means it will come back, the maximum force is permitted, up to that force the body will come back to its original shape when you will remove this force, right. So, now here stress and strain, stress is defined by force per unit area F by A. So, now so I told these 3 ways we can deform the solid. So, basically that is and the force is applied in 3 ways basically. So, those force are basically called tensile stress. Now, this force is in terms of stress. So, we tell this tensile stress, one case is tensile stress that produce a change in length, another case shear stress deforms the object at a certain angle, that is as I told that just it tilted this body tilted I showed you. So, shear stress deforms the object at a certain angle, and compressional stress or volume stress that basically produces a change in volume. Okay. So, that example I showed you, this if body is put in a liquid. So, that this type of force basically, that is pressure basically, force per unit area it is again is called pressure. So, in case of bulk stress, so that is that we can consider it as a pressure. So, when an object is subjected to a stress, whether tensile stress or shear stress or compressional stress, so there will be so it will suffers, it will so it suffers a strain. Okay. So, it will be deformed, and then that is basically we express in terms of strain. So, what is strain? So, again strain also in 3 types. So, when we apply tensile stress, so then there will be tensile strain, and tensile strain is basically the ratio of change in length to original length. Okay. So, this is del L by L. If this change of length is del L and original length is L. So, del L by L, that is the tensile strain. Okay. So, this according to Hooke's law, this stress by strain, that is the elastic modulus. So, in case of tensile strain and stress, so this ratio of tensile stress and tensile strain, so that is the give elastic modulus. That elastic modulus is called Young modulus. Okay. So, for Young modulus, this stress is F by A and delta L by L equal to, of course. So, that elastic modulus, that Young's modulus in this case, and this we express generally in terms of by this y, capital Y. Okay. So, other strain, this volume strain and bulk volume strain. So, that is the basically ratio of the change in volume to original volume. Okay. So, from there people can find out the bulk modulus. So, bulk modulus is equal to volume stress by volume strain. Okay. Similarly, for shear strain and shear stress, so that elastic modulus we tell, that is the shear modulus. Anyway, so now our topics is basically to determine the Young modulus of a material. So, here what is Young modulus? Just I refreshed it, just I repeat it. Okay. You know, but still the parameter we are going to measure from basic concept how it has come. So, here just I mentioned. Okay. So, that means for doing experiment, here it is clear that for doing experiment we have to apply stress, tensile stress, okay, or force over a area, and then stress will be force per unit area, okay. And then we have to there will be strain, tensile strain, and that strain we have to basically measure. Okay. So, for Young modulus I need to apply force, then I need to measure the original length, then I need to measure the area over which this force is applied, and then I need to measure the elongation, okay, delta L. Okay. So, we have to design experiment. This formula will take different form depending on the design of the experiment. So, basically in laboratory there are two methods generally we follows to measure the to measure the Young modulus of a material. So, this these two method is basically is called flexion method and another method called Charles method. Okay. So, in flexion method we take the material in a rectangular form, in a bar form, or we tell beam. Okay. So, that I will define, and then Charles method we take the metal in form of wire. Okay. Now, in this method we are measuring the Young modulus of a beam or bar or cantilever, we tell cantilever also, cantilever beam, and in this method we are measuring the Young modulus of wire. So, now question is whether we are measuring. So, this if both wire and this bar is made of same material, say steel or copper, whether the Young modulus will be different or same. Okay. Does it depend on the shape of the material? So, Young modulus is basically the property of the material. It does not depend on the shape and size of the material. Okay. So, for experiment we can take the metal in form of wire, that is basically cylindrical form, or in form of bar, okay, that is the rectangular form. So, since in our laboratory we are going to measure the Young modulus of some material, I think material is steel, using this flexion method. So, I will discuss here now this method, about this method before going to the laboratory. So, let us see what is flexion method. So, as I told that in flexion method a bar or beam of the material is taken. Okay. So, the material, the Young modulus to be find out for this material is taken in form of beam or bar. Okay. So, a bar have length say capital L, it has width or breadth, that is B, and depth or thickness, that is D. Okay. So, it will be bar this condition of beam or bar, basically L length, it has to be very greater than breadth, and breadth has to be again very greater than thickness. Okay. So, then we tell this shape, we tell that is the beam. Okay. So, this type of beam one has to take, okay, which is having length L, capital L, breadth B and depth D. So, now for this experiment there is a geometry of the experiment is basically this beam we placed on a two sharp knife edge, okay, on a two support, on two support. That support is basically it's a very sharp edge, knife edge. Okay. So, on this sharp knife edge we will place the bar, we will place the bar. Now, then this effective length of this bar is basically between distance between these two sharp edge, right. So, that one has to measure this length. So, this length, typical length generally we take between 80 to 100 centimeter. So, we will use for this, which instrument we will use? This is a meter scale. Meter scale we will use to measure this one, and meter scale, what is the least count of the meter scale? Generally it is 1 millimeter, fine. So, then next what we will do? We will apply. So, we need also then length I need, that is fine. We may need breadth and thickness, breadth and width also, okay. Breadth or width, thickness or depth, okay, that also may we need. So, what we need to, so experiment is that this we will place the bar on to sharp edge. Now, in middle, exactly in middle we will put weight, means we will put weight. So, due to this weight, so there will be force, gravitational force, right. So, this beam will bend. So, this beam will bend, basically this beam will bend, okay. So, this beam will bend like this, beam will bend like this, okay. So, yeah, I think we will see. So, beam will bend. So, now that what is the original position? Now, it will bend. So, that means this middle point will depressed, will go down, it is depressed basically. So, how much it is depressed, that will measure. So, anyway, so this is the geometry. So, we will put weight and there will be depression. So, that depression, how much depression, that we have to experimentally measure. But what are the parameters we have to measure? So, for that we need the final formula for this geometry of the experiment. We have to find out the working formula. We have to find out the working formula from the theory. So, here this is calculation for this theory is slightly longer. So, I will not calculate that one. I will give basically this calculation as a supplementary materials. So, just what is the final result from that calculation, here I have shown. So, that y equal to g L cube, capital L cube, that is the length of the bar, that is the effective length of the bar, that L cube, by divide by 4 b, that is breadth, and d cube, that is the depth of the bar, and this m by L. What is m? That load, mass, at the middle point we are putting the mass, okay. So, that is the m, and what is the small l? That is the basically for each mass, what is the depression of the cantilever, of the middle point of the cantilever. So, that is the small l, okay. So, this is, we tell this the working formula for the experiment, okay. So, now we have to look at this working formula, what are the measured parameter that we have to decide, and then for that you need arrangement for the tools, okay. So, then you have to perform the experiment, you have to measure the parameters one by one. So, here clearly one parameter is length, okay, effective length. So, we will use meter scale, this breadth is the B. So, we will use the slide calipers for this and D, this is the depth. You can use slide calipers, but here we will prefer to use screw gauge. Now, question is why? Because in error analysis you have seen that this error over D will come, that will be 3 times of the least count of this instrument. So, so if we use the slide calipers, so what will be the error over D? If you use the screw gauge, then error will be much smaller. So, to reduce the error, so you should, depending on the power of the parameters, you should choose, you should choose the precise tools. Okay. Now, then this other part we have to apply the load and measure the depression. So, for measuring depression, we will show our arrangement. There you will see we will use travelling microscope, and this I will show the travelling microscope and describe what it is and how it is used. So, I think this the preliminary preparation for before starting the experiment. Now, let us go to the laboratory and perform the experiment, that I will show you in next class. So, thank you for your attention.